Hey everybody, what's good? What's going on? JB here, back with another live stream on CyberInsight. Today I wanted to continue going through some of the TryHackMe Pentest Plus rooms. As I talked about in a previous video, I was starting to do a little bit of studying for the Pentest Plus. And I think about a week ago we did the room covering the Nmap stuff. So today I thought it would be cool to kind of go through another one of those rooms. We're going to do the Introductory Networking room, which kind of is going to go over some high-level networking information as far as like the OSI model and how data encapsulation works. It's going to have us take a look at doing a little bit of analysis on a pcap file. So the pcap is going to be a packet capture of some live traffic going back and forth across the network. And then there's a few different troubleshooting tools or commands that we're going to do a little bit of research and investigation with. I think it's ping, traceroute, dig, and Whois, I think is the fourth one. So yeah, we'll kind of see how this goes. I haven't actually gone through this room yet, but it is introductory. I'd assume that the information covered in it, while it's a room that is in the Pentest Plus learning path, this is probably a room that's good enough for anybody who's trying to, learn some fundamentals about networking, whether or not you're going after Security Plus or Network Plus, or not even going after CERT, but just trying to understand how the basic fundamentals of a network is and kind of how that communication happens. So, yeah, before we jump into that, I appreciate it if you smash the like button, and if you aren't already subscribed, go ahead and do that too. If you enjoy the content, share it with other folks. Yeah, so let's jump into that. I'm going to move over to my browser, and as we're going through this, if there are any questions and stuff like that, as always, just throw those in the comment section, and we'll hit those up as we go through it. So, all right. Uh, with this, I already set up the browser-based server that they have to be able to get in, to be able to do commands and stuff like that. So whenever you end up doing any of these rooms, you're going to want to turn that on and stuff like that. That normally takes about 5 minutes or so, but I did that a little bit ahead of time. So intro, as far as what we're going to be talking about as we go through this room, the OSI model, the TCP model, which is kind of something that's similar to that, but a little bit more compressed. How these models look like in practice. It's kind of walking through the different levels of those models and what kind of resides at each level, and then some basic networking tools. So I think if we look down kind of at what we have here, I mentioned ping, traceroute, Whois, and dig. So we will kind of dig into that and go from there. So let's move on to the OSI model overview. Now, I could go through here and read all of this to you, but I am not going to do that because I think that would be kind of really boring. So I'm just going to give you a breakdown of what I think the OSI model consists of off the top of my head, and we can kind of just go from there. So you have 7 different layers within the OSI model. Application layer is a top layer, and that's really going to be whatever the application is that resides within your computer or server. So for instance, if we're talking about a web browser, or we're talking about some other type of service that we're using, so like a DNS or something like that. At that point, that's kind of where we're talking about port numbers, right? So you might be familiar with hearing about different types of port numbers, whether it's going to be 80 for like web traffic, unencrypted web traffic, HTTP, or 443 is going to be the encrypted version of that, HTTPS. And then there's different flavors of that depending upon the transport protocol that goes along with that. And we're going to hit that up once we go down a little bit lower. Presentation layer has to do with how the data that's coming from that application is actually translated, I guess would be the right word. So you might see some different types of things at layer 6 for the presentation layer. So like JPEGs, right, would be a way that data is presented a different way. Movie files, MP3s. That's also where compression and encryption ends up happening. So encryption, dealing with TLS and stuff like that, that encryption actually happens at that layer. Layer 5, which is a session layer, has to do with kind of taking all of these different bits of data that's coming down from all these applications and keeping them segmented once they're passed down to the lower levels. So if you have different types of data either coming back up to go to different applications or being sent from different applications, once it's being passed down to the transport and IP layer or the network layer, the session layer is going to kind of keep track of these so that your computer and the applications don't get confused, and you don't necessarily have data coming in that's supposed to go to one application going to another one. Hey Kiki, what's going on? Just seeing you dropping in there. Or displayed at the presentation layer. I'm not quite sure what you mean by that, but the application's data is displayed, or how it is displayed kind of is coordinated at that point. Yes. Let's see. Transport layer. This is going to deal with the communication, how stuff goes from the source to the destination. There's a few different types of protocols that reside at this layer, but the two main ones that we deal with the most is TCP and UDP. TCP is Transmission Control Protocol, and UDP is User Datagram Protocol. The main differences between these is TCP is what they call connection oriented. So that means that when it sends something from the source to the destination, it actually has a handshake that's done to set up to make sure that everybody is on the same page as far as with what they're doing. And it also does different types of flow control and error correction. So if you send some traffic to the distant end and it doesn't receive it, it can do a request to retransmit that data so that stuff doesn't get lost. This works really well when the integrity of whatever it is that you're sending is really important. So for instance, when we're talking about surfing a website or something like that. The UDP type of traffic, though, is what we call connectionless. It's more kind of like spray and pray. You don't really care about any type of error correction or retransmitting of data. Where this kind of comes into play and is useful is when we're talking about stuff that is real time. So if you're doing voice over IP or some type of real-time VTC, video teleconferencing, right? You can't really go back and correct for data bits that you miss along the way because you're already further along in your conversation, right? That would be really awkward and create a whole bunch of problems. So really UDP, we just kind of, try to make sure that we have, some quality of service in place across the network, do some other types of things to try to ensure that the pathway to the distant end is efficient, but we don't actually do any type of real retransmission or error correction in the way that we do with TCP. It is also worth pointing out that with a transport layer, that is where ICMP lives as well. And ICMP is what we use for a lot of different type of troubleshooting. So whenever you use like the ping commands and things like that, that resides at layer 4 as well, the transport layer. Moving down the stack a little bit more is layer 3, the network layer. You're going to know this primarily as where IP addresses reside, right? And so this is where your logical addressing of the IP addresses and routing and all that type of good stuff happens. We move down to layer 2, talking about the data link layer. This is going to be where you're going to have your media access control. This is going to be where your physical addresses associated with your NIC are going to reside. This is, like the MAC address. This is also kind of like when we're talking layer 2, that's going to be all within the same VLAN, all within the same subnet. There's no routing happening between two different networks. It's all within one network, and all that communication happens with the MAC addresses and not the IP addresses. And then we get all the way down to layer 1, which is the physical, which is the actual real electrical signals or light signals, depending on whether or not we're talking about copper or fiber cables. So that was me trying to summarize that all off the top of my head. Hopefully I didn't make any type of major mistakes with that. It is kind of worth noting, since I do like to try to present this in a way that kind of makes sense. I made this infographic a while back kind of explaining the different layers and applying it to like what happens when you go to Netflix, right? So I can put a link for this in the description, but it's pretty much talking about the same types of thing. You know, your web browser is going to be at the application layer. Presentation is going to be doing the TLS encryption and some of the other what's the word that I want to use? The way that the video file is actually formatted. Session is, as I mentioned again, kind of making sure that the application data that's going to the specific browser and stuff like that is actually, you know, what it's supposed to be, and I'm not actually sending something else to the browser. Transport, we talked about using TCP. In this case, because it's not live video, UDP would be good for live video. Networking, at the network layer, we talked about IP encapsulation. Layer 2, the MAC addresses, and physical is my ones and zeros going across the wire so I can watch Ozark or, I don't know, whatever else is good on Netflix. I must have been watching Ozark when I made that infographic. So let's go back and take a look at these questions here, and we can see if we can kind of get through these. So what layer would choose to send data over the TCP or UDP? So we kind of talked about that being the transport layer, so that would be layer 4. And if you need a mnemonic device to remember how the OSI layer works, you are out of luck today because I don't have a good one for you. So go to Reddit and Google something there, because I'm sure somebody has something a lot more wittier than what I can come up with right now off the top of my head. Which layer checks received packets to make sure that they haven't been corrupted? Well, that could be layer 4 as well with the TCP type of error correction. Let's see if I do that, if I'm going to get that wrong. Yeah, they don't like that. Maybe that's going to be session. Yeah, we could go with session on that. Let's do session. Uh-oh. Packets. Well, packets are a layer 3 thing. Let's see if there was anything else for error correction. I don't see anything. Try 2. I mean, we're going to just try all of them at this point because... Oh, it does help when I put it in the right one, doesn't it? Let's see. 2. Let's try 2. Ta-da! Where did you catch that on there? Because they were talking about packets. It receives a packet. The thing that threw me off on that is layer 2 doesn't use packets, it uses frames. So that's a trick question. Which layer would data be formatted in preparation for transmission? So I think that that is going to be back up at the presentation. Because that's what I think of. I think of layer 6 when talking about formatting. So let's see. Uh-oh. So they don't like that either. Let's see. Correctly formatted. Yep. The data tends to be in a format that the application understands and is not easily understood by the application layer and the into a standardized format, as well as formatted in preparation. Well, see, like this said that it receives the correctly formatted data from the presentation layer. That's why that is throwing me off. I know. No, I didn't like that one. We could do 5. I swear that I In preparation for transmission. That's wild. Nope. Really? Well, we're at the point where we're just hitting numbers here. I mean, that does not make any sense whatsoever. Exactly. 1, 2, 3, 4, 5, 6, 7 at that point. It, yeah, okay. At which layer transmits and receives data? That's going to be the physical layer. Which layer encrypts, encompasses, and otherwise transforms the initial data into standardized format? That's going to be presentation. Which layer tracks communication between hosts and receiving computers? Tracks communication between hosts and receiving computers. I'm going to think that that's going to be transport. Oh, I was hoping that I could. Let's see. Nope. Oh, session. Yeah, there we go. Which layer accepts communication requests from applications? That'd be 7. Which layer handles logical addressing? That's going to be 2. No? Oh, logical addressing. No. IP addresses, not physical addressing. There we go. That's again, I read that and I thought logical link instead of that. Okay. When sending data over TCP, what would you call the byte-size pieces of data? So when we're talking about the transport layer, there's either datagrams or segments. Datagrams, I believe, is with UDP, and segments is with TCP. Let's see if that was... Yep. It also helps to remember UDP. When we were looking at that up there is user datagram protocol. So it actually has datagram in the name, so pretty easy to remember. Which layer would the FTP protocol communicate with? Well, I'm going to say that's an application. Whoop, whoop. Let's see what they would have said on the hint there, just for kicks and giggles. Oh, it's telling us what FTP is. FTP allows you to transfer files back and forth. It is unencrypted, though, so be careful when you're using that. Which transport layer protocol would be best suited to transmit live video? Well, I talked about that a few times. That's going to be UDP. Not UMP, UDP. It really wants to autocorrect that. There we go. All right. That was fun. All right. Encapsulation. So the important thing with encapsulation is to realize as you continue to go down the stack from, so let's say you're on the source computer and you're going to send a request to a website to grab some data, right? As you continue to go down all these different layers, starting up at application and working your way down to layer 1, the data continues to be appended by headers at each of those different layers, right? And so you start off with your data up at the application, has some header information, gets passed down. That data then gets more header information attached to a presentation, same thing down to the session. And then at that point, we start to get into the transport layer, and that's where you're going to see stuff with the data and it being the segments of the datagrams. So that's where we're talking about the difference in that terminology between segments and datagrams. From there, that gets passed down to the network layer, gets encapsulated again, and at that point, that's going to be called packets. Then that gets passed down again, down to layer 2, and that's, at that point, it's called frames. It is interesting to note that with the data, once it gets down to layer 2, it actually has both a header and a trailer wrapped around those frames. Where you see with the rest of those, we didn't have that. And then by the time it gets to layer 1, it's actually, ones and zeros, electrical signals, light signals just going across the line. Let's see if there's anything else that's kind of worth going over with that. So that's kind of it going down, gets sends as the bits all the way across to wherever the distant end is. Obviously, depending upon your hops throughout the network, it's either going to be kind of going back up to layer 2 when it's being switched, or to layer 3 if we're talking about routing of the packet between multiple networks. Once it gets to the destination network, though, and gets to the host that it's supposed to be going to, then it's going to work its way back up the stack at that point and kind of have those headers stripped off all the way until the point where it gets to the layer 7 or application layer, where it just is the data going into the application. Let's see. And they're talking about reversing that process, de-encapsulation. Yep. Cool stuff. All right. How would you refer to data at the layer 2 encapsulation process? We called that frames. Okay. How would you refer to data at the layer 4 encapsulation process if the UDP protocol is selected? Well, remember in the one that we just did, TCP with segments, UDP is datagrams. Okay. What process would a computer perform on the received end? Well, on the send end, it would be encapsulation, right? And then on the receive end, it was de-encapsulation. And let's see how particular this is with wanting the hyphen in here. De-encapsulation. Let's see if they like that. There we go. Okay. Which is the only layer of the OSI model to add a trailer during encapsulation? Well, I mentioned that, didn't I? So that is the data layer, data link. And does encapsulation provide any extra layer of security? Sure. No. They want aye or nay. I mean, encapsulation by itself isn't necessarily providing any like encryption or anything like that. Let's see. This is a guess. No. Yay, they want yay. Okay. Let's see where they actually say that in there. What? Oh, A. That helps if I spell it correctly. There we go. Let's see if they actually mention that in there. In this example, link and this also adds its bonus of increased security, as the data can't be intercepted and tampered with without breaking the trailer. Oh, talking about layer 2. Okay. Cool. All right. So we talked about the OSI model. The TCP/IP model is kind of similar to that. I actually think that the TCP/IP model came out first. See if they say that. The TCP in main way is very similar to the OSI model. It's a few years older. Okay, yep. Came out first. And you kind of see how instead of it being 7 layers, it's 5 layers. Pretty much they just take application, presentation, session and bundle that all into what falls in the application layer for TCP/IP. And then data link and physical, they call that the network interface. Transport stays the same, and network becomes internet. We talked a little bit before about TCP and how it's a connection-based protocol. And we talked about how there's kind of this initial handshake that goes back and forth. So what happens is the client wanting to connect to the server sends a SYN message like, hey, what's going on? The server ends up sending back a SYN and an acknowledge message back to the client saying like, hey, what's going on? And yes, I did get your message. And then the client sends back an acknowledgement being like, hey, I got your acknowledgement back, so we're all good. And at this point, we can go ahead and start actually transmitting data. Anything kind of interesting else to add here? No, I don't think so. I think that kind of hits the high levels on those. Let's see. Which model was introduced first, OSI or TCP/IP? TCP/IP. Which layer of the TCP/IP model covers the functionality of the transport of the OSI model? Well, if you remember, the transport actually stays the same, is named the same in both of those. Which layer of the TCP/IP model covers the functionality of the session layer of the OSI model? Well, if you remember, I said that the top three layers, layer 7, 6, and 5, so application, presentation, session, are all bundled in the application layer. Network interface layer of the TCP/IP model covers the functionality of two layers of the OSI model. These are the data link layer and the physical. Okay, which layer of the TCP/IP model handles the functionality of the OSI network layer? That is the internet layer. Okay. And what type of protocol is TCP? We're talking about the fact that it is connection oriented. And they probably want that hyphen connection oriented. Let's see. Now what? Let's see what they. What they want for that. Transmission control between two endpoints, blah, 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 blah. Connection based. Okay. Not connection oriented. Connection based. Okay. What is SYN short for? Synchronize? Yep. Okay. Synchronize. Synchronize. Did I spell that incorrectly? I don't think I did. Let's see. Oh, okay, yeah, it was with an S instead of a Z. Cool. What is the second step of the three-way handshake? So remember, the client sends to SYN, the server sends to SYN-ACK. Yeah, it's synchronized, but for some reason they're doing the British spelling of it and spell it with an S instead of the Z, for whatever reason. Okay, we were saying that was SYN, ACK. And what is the short name for acknowledgement? Well, we just said that, ACK. Cool. Kiki, you're killing it over there. All right. Task 5. And I'm going to take a sip of water. All right. So we're talking about basic theory of kind of how all this stuff works, and we're going to use Wireshark. If you've never used Wireshark before, it is a free tool. It allows you to actually capture traffic that's going through your network interface card on your machine. You also can take what's called pcap files or packet capture files that were captured someplace else and put it into the application, and you're pretty much able to analyze the back and forth of this network traffic. I have a few different labs that I've done previously that actually go over how to use Wireshark, do a whole bunch of other analysis, a lot deeper than what I'm going to do just in this little scenario here. So if you're unfamiliar with it and you want a little bit of a deeper dive into that, go back on my page, check out my Network Plus lab videos. I think there's 2 different Wireshark labs in there, and they're great. They'll get you set straight and get you all excited about using Wireshark, which is a great tool. And no matter whether you're in cybersecurity or IT, it's something that you're going to be using either from a security perspective or from an operational perspective when you got to do troubleshooting. All right, so we have this download task files here that we needed to download. And this is actually what it looks like. And I'm going to pop up my Wireshark with this file in here in a second once we get down to what the questions are. But this is them looking at the first packet here. As you can see with that, it has a timestamp, source IP, destination IP, protocol, so HTTP is that first one, and then a little bit of info. And as you kind of dig down through this, it has different sections that kind of correspond to the different layers that the packet or that the data goes through. So even looking here, right, we have a frame, which is going to be talking about dealing with the bytes, and that's going to be like the physical layer. Then Ethernet 2 and the MAC address is dealing with layer 2 or the data link layer. Then we see IP here is the IP addresses, source and destination. Obviously, that's dealing with the network layer. Then there is TCP information, so the source and destination port. Remember I was talking about port 80, in this case TCP port 80, being used for web traffic for HTTP. Good thing to point out is that TCP port 80 and UDP port 80 are completely different ports, right? So UDP port 80 does not correspond to HTTP. Worth pointing that out. So whenever you are looking at stuff, you do want to make sure that you are using the right TCP or UDP and the correct destination port with that. And then this last part here, the hypertext transfer protocol, is dealing with the application layer. And in this case, it's talking about the HTTP GET. We can click down into all of these and take a look at other information that's within those fields. So let's take a look here and see what this first question is, and then we can go over and kind of hop back and forth and kind of go from there. So what is the protocol specified in the section of the request linked to the application layer of the OSI and TCP models? So what application layer is being used in the second captured packet? So let's take a look and hop over into the Wireshark. Let me blow this up maybe a little bit more so you can see that. Hopefully you can see that okay. And we're going to click into this. And so what we can see, the protocol is going to be right here, domain name system, so DNS. It's a DNS query. So we can go back and put domain name system as the answer for that. And let's see. Domain name system. Okay. Which layer of the OSI model does the section that shows the IP address 172.16.16.77 correlate to? So we already know just from looking at this here, and we kind of broke this down here, the IP address section here deals with the network layer. And they are asking for the OSI model and not the TCP IP model, because if they were, then it would be internet. Okay. In the section of the request that links to the transport layer of the OSI and TCP models, which protocol is specified? So if we go back, if you know what transport protocol DNS uses, then you would know the answer to that already, but we will dig back in here just so I can show you. And so we're talking about here destination port 53, and it's UDP, so user datagram protocol. So let's go back over here and go user datagram protocol. Datagram protocol. Okay. Over what medium has this request been made? Linked to the Ethernet data link layer of the OSI. So see if we actually, without me having to hop back over there, we saw that it was Ethernet 2. So we just put that there. I don't know how to write. Looks like II. I don't even know if that will take that. I don't think it will. Oh, it will. Okay, perfect. Which layer of the OSI model does the section that shows the number of bytes transferred link to? And remember, we talked about that up here. This frame section here and the bytes corresponds to the physical layer. I don't think I needed to write physical layer. Let's just go physical. Yep. Can you figure out what kind of address is shown in the layer link to the data link layer? So data link layer is the second one here, and we would know that these here are MAC addresses, right? We're talking about the physical address that's assigned to network interface cards. So MAC. Cool. All right, so now we are getting to the part where we're going to hop over and actually do some commands in the browser. So we're going to go over ping, traceroute, Whois, and dig. If you are doing these for yourself through here, both Traceroute and Whois were not installed by default on this computer, so you actually have to do like a apt install or apt-get and whatever the name of the application or the tool is. Pretty much if you actually just type in the command to do it, it will tell you it doesn't exist and tell you the command that you need to install whatever the tool is. So no big deal, but something to keep in mind if you are actually going to go do this for yourself after the fact. So we're going to do some ping commands and hop back and forth here. So they want us to ping bbc.co.uk. And they want to know what the command is for that. Well, we'll just type that in here real quick. Whenever you're going to ping, it's just going to be ping bbc.co.uk. And we'll submit that. And we'll go do it so you can see what it looks like. bbc. What was it? .co.uk. .co.uk. Right, and so the cool thing with ping, when you do this, I'm going to hit Control-C to stop the ping, otherwise it will continue going forever. If you do that on a Windows machine, it will just do like 5 pings, and then you're good, or 4 pings, I forget, 4 or 5. The cool thing with this is it's a good way to test DNS resolution, because you're pinging a domain name, and what it's going to do is it's going to be forced to do a DNS lookup to find the IP address to be able to do the ping. So it's a good way to be able to tell if DNS is working in your environment. And then we see the sequence and time to live. And then this is important here. This is the round trip time between the device and the host device and the destination device. So you can be able to tell, if you have a whole bunch of latency somewhere in the path. All right, let's go back and take a look at what the next question is here. Ping this URL. What is the IP address? So that is Muirland Oracle. Muirland Oracle. .co.uk. Okay, so that's going to be 217.160.0.152. Let's see, 217.160.0.252? 152. Okay. Submit. Cool. All right. Which switch lets you change the interval of sent ping requests? So this is a good thing to know whenever you're dealing with any of these tools or commands, specifically within Linux, is you can use what's called a man command, which is short for manual, and it will give you a whole breakdown of all of the different switches or different types of configurations you can do with these tools to get them to do different things. So if we type man and ping, it's going to give us a whole bunch of different options for different things we can do. You hit spacebar to kind of go down I mean, so we could specify IPv4 only. We could specify the interval, which I think is what they were asking for. So it's a -i or -i. Interface that you go out of, a whole bunch of different options here. So let's go back and go dash lowercase I. And that's it. That's an important thing to realize too, is whenever you're dealing with those switches, a lot of times there might be something that is lowercase and there might be something else that's capital. So you always want to double check to make sure that you're using the right one. Which switch would be used to restrict requests to IPv4? We actually already saw that. So it's -4. Okay. And then which switch would give you a more verbose output? That is going to be all the way at the bottom of this. I believe it's -V, but we will double check. Oh, just went past it. Yep, a -lowercase v. Okay. Cool. So that is good to know. Like I said, whenever you want to get to know and try out different things with these tools, definitely use the man page on those to figure things out. All right, so Traceroute is kind of uses ICMP as well, but what it's going to do is it's going to show us each of the different hops along the path between the source and the destination. Sometimes you might not actually get every single path in there depending upon the type of filtering that's happening across the network. So take that with a grain of salt. But it should give you a pretty good idea of what's going on. You can do this both in Linux with a traceroute command or in Windows with the traceRT command. It's worth noting here the differences between using ICMP versus UDP for the Unix stuff. So this is actually one of those things that I used in the Wireshark labs that I did, and you could actually see the traceroute traffic. Some, I believe, is going out ICMP, and then the response is coming back UDP. So let's take a look. And we're going to do a traceroute to tryhackme.com. And to get out of the man page, you just hit Q. Traceroute tryhackme.com. And then we have a whole bunch of all these different hops and the different times between the hops. Again, this is a good command for being able to troubleshoot if you have any path through the network, if there's any certain devices that are causing a lot of latency. So we completed that. Which switch would you use to specify interface when using traceroute? I bet you it's going to be -I, but let's see. So we'll go to the man page. Let's see. TCP gateway. Yep. -lowercase-I. Okay. Which switch would you use if you wanted to use TCP SYN requests when tracing the route? I think we went above that. Yep. So it's going to be -T. Go with that. And what layer of the TCP IP model will Traceroute run on by default? So we were talking about Windows before, and I think that let's go transport. No. Interesting. Internet. Okay, cool. Let's see. All right, so now we're going to move on to Whois. So Whois is a cool command. It kind of gives you a bunch of information about domains. So you can see here you do Whois and then this BBC website, and it's going to give you the name, where it was registered, the dates it was registered on, the authoritative name servers for it. So the servers that are actually hosting and responding back to domain requests for that particular domain. Let's see if there's anything else that kind of makes sense in here. Yeah, I think we'll just jump into it. If you got any questions as we're going through here, throw them in the comments section. Let's see. All right. We're going to get out of that. And who is Facebook.com? And let's see. Let's just make that bigger. So we got a whole bunch of information that comes out of that. Right? So, let's see the domain name, when it was updated, when it was created back in 1997, name servers, all that good stuff. So, what is the registrant's postal code for Facebook.com? Let's see. They should have... registrant ID, domain admin, Facebook.com, 94025. And let's go. When was the Facebook domain first registered? We saw that was 1997 0329. 1997 0329. So let's go 0329 1997. No. Did I do that incorrectly? Let's see. Oh, yeah, I did do it incorrectly. They want it the other way around. 2903. Submit that. Cool. Perform a Whois on Microsoft.com. Let's make sure. Whois Microsoft.com. Yep. Yep, it's date, month, year. Yep. Let's see. So we did it on Microsoft. Let's see what questions they want here. What city is the registrant based in? Redmond, Washington. What is the name of the golf course that is near the registrant address for Microsoft.com? Oh, we could go through that, but we're gonna skip over that. I don't feel like going through some OSINT stuff on Google, but yeah, that should be easy enough to do that. What is the registered tech email for Microsoft.com? Let's see. It's going to be msnhost@microsoft.com. Host@microsoft.com. Yeah, we aren't turning this into an OSINT lab, which would be perfectly fine. I'd be completely cool with doing an OSINT lab, but I don't feel like doing that today. All right, so let's move on to the next one. All right, so Dig is cool, and if you checked out, I did a Linux Plus lab like a week ago or something like that. We went all over the Dig command. Same thing with like the host command. Kind of the stuff that you're going to be using this for is to look up information about a domain and what server is responding back for it. So let's see. What is kind of important to understand within this? So on your local network, whenever you go to do a domain lookup, first thing you're going to do on your computer is going to look for it in its local cache to see if you already have the IP address associated with the domain that you're going to look up. If you don't have that, then it's going to go, and your computer is normally configured to point to what's called a recursive server. Recursive DNS server is then going to send that request out to the internet to go through this whole crazy chain of going to the root servers, then going to servers that are kind of down this other hierarchy, going down the top level domains and further down until you get to the point where you end up at the authoritative name servers for whatever the domain is that you're trying to go to. Hopefully, if it's a domain that other people in your environment have already tried to find, then the recursive DNS server will cache whatever that is. So like, you're in your office within your organization, everybody's already going to Google. So hopefully that's already cached on your recursive server and it doesn't need to actually go out and go through that whole process. Let me think what else is kind of interesting. Top level domains, we were kind of talking about those being, .com, .org, things like that. Time to live on the DNS request, how long it will be valid for. That's probably something else kind of interesting to know. Do they mention it here? I'm sure they do. Yeah, TTL. Okay. That pretty much is telling your computer how long the DNS record that it queried is valid for. And worth noting that TTL in the context of DNS caching is measured in seconds. Okay. What is DNS short for? Oh my goodness. I think that we already covered that a while back when we were talking about that, but domain name system. What is the first type of DNS server your computer would query when you search for a domain? I mentioned that recursive. Cool. What type of DNS server contains records specific to a domain extension? So .com, .co.uk. So we were saying top level domain. What is the very first place your computer would look for to find an IP address of a domain? I think I said that was what? Local cache? Google runs two public DNS servers. One of them is 8.8.8.8. What is the other one? Does anybody know what that is? If you do know what it is, drop it in the comment section. I know what it is, but we can see if anybody else knows off the top of their head. And I'll give you a hint. It's similar to this address. And if nobody knows what it is, then I will tell you. I believe it is 8.8.4.4. Nope. Ooh, okay. Oh. Yeah. Didn't need that extra period at the end. If a DNS query has a TTL of 24 hours, what number would the dig query show? So remember, it's in seconds. So 24 hours. Let me grab a calculator real quick. I should know this off the top of my head, but let's go 24 times 60 times 60. Yes, of course that looks super familiar. 86,400. See that a lot with IPsec configurations as well. 86,400. There we go. All right, so that is it. I guess I could go and do that OSINT thing after the fact, just so I can close this out. But I'm not going to do that right here with all of you. Let's see. Move back over to the screen here. And there we go. All right. So, yeah, appreciate all of you sitting through on this. Got a decent amount of folks here on the stream, so that's pretty cool. Hope everybody enjoyed that. Hopefully that was useful. I'm going to keep doing these Pentest Plus, TryHackMe room walkthroughs and stuff like that. Might do if they have a few more networking ones. So maybe we could do those before we get into like the Metasploit. Trying to remember what other ones they have. Nessus, Burp Suite. I think there might be a Wireshark one, a more in-depth Wireshark one. But anyway, hope everybody enjoyed that. If you do have any other questions, you can throw those out right now. If not, then yeah, appreciate you guys hanging out. Hit the like button if you haven't already. Share the video with other folks that you think might be interested or might find it useful. And yeah, I think I'll have a few more videos this week. I think we're going to wrap up the how to build secure networks series that we've been going over. So, all right. Well, I don't think anybody has any questions. So hope everybody has a good evening, and we'll chat later. All right. Bye.